Okay, and we are live. So welcome everybody to this Kubewarden office hours for June. Today is June 13, and as usual, we have the office hours, which are open to everybody that would like to join, and for which the topics are all public. And with that, I want to remind you that you can find the list of the topics for today, the agenda, on this Google Docs that it's linked on kubewarden.io for the office hours. It's at the bottom of the page. So for today, welcome everybody. Welcome for those that are listening to us and looking into this recorded. What do we have? We have here some people from the Kubewarden team. You can see. I don't know if you can see the whole panel. We have Jose.
Oh, hello.
We have Flavio also.
Yeah, hi everybody.
And we have Fabrizio.
Hi.
And for today, the topics are the 113 release, which the Kubewarden team did last week. And then we have also the cell policy, which we have done a bit of spoilers in the past, and now we are close to completion. And then what's coming next? In that case, would be the group policies, which we will talk about, and then the release of 114 and what does that entail. So for the 113 release, we achieved several things, and as you can see in the agenda, we reduced the PolicyServer memory usage. So I suppose maybe that's a topic for Fabrizio.
Yes, I'm gonna share my screen, and you should be able to see our RFC. Okay.
Yes, perfect.
Okay, so we started from this issue, which was pretty old, and basically we had some users from community. They were complaining about the PolicyServer being killed by an OM killer in the Kubernetes cluster because it was consuming too much memory, and especially this was happening in a big cluster, which is pretty huge. So the cluster was listed here. This is the inventory. It had like 3,000, more than 3,000. Sorry, yeah, 3,000 namespaces, 10,000 ingresses, and a bunch of other resources. And the main reason is that when using context-aware policies, which are policies that can access the state of the cluster by doing calls to the API server, or actually to our policy server that then calls the API server. We introduced in, I think, 1.12 or 1.11 an optimization to be faster. So we were basically caching the state of the cluster by using some tool, which is called the reflector, which is provided from Kubewarden. It's also provided by the client Go, but it's kind of like low level in the client Go. And so the reflector is basically something that watches. It's a watch plus a store. So it watches the state of a certain resource, and it pulls by using some filters all the resources that are interesting for our policy, and then it stores them in memory. Okay, so the first thing is to consider is that this reflector is lazy, which means that we do not start a reflector each time that we start the policy server, but we wait for the first policy that asks for some resources to come, and then we basically fill the store and answer to the policy. And also to note that we already do some optimization in the store side by pruning data that are not useful for policies, such as like Kubernetes managed data or annotations that come from kubectl. So the store should be pretty compact given the number of the resources. However, the policy was bursting a lot and having this memory consumption that was causing the OM killer to intervene. And also after the burst, the memory consumption was constant. So you had like a burst of 1 GB, and then the PolicyServer from that point on was consuming 1 GB of memory and never releasing this memory to the OS, which made a good candidate for the OM killer to kill the process. And
a silly question.
Yeah.
So the 1 GB is for this specific test case, no? For this specific cluster with this amount of resources and so on.
I will show some data soon, but 1 GB of idle RSS, like more than 1 gigabyte. With idle, we mean that we had the first call, we filled the store, and there are no policies that are hitting the PolicyServer. So it's not a spike because we are serving a lot of requests. It's just a spike because the PolicyServer has requested that kind of memory to the OS, and it's keeping that for well, actually, there are a bunch of reasons why it keeps that, but because it might need it in the future since it needed it for a burst. Okay, so that's the main reason. And this is just only with 10,000 role bindings, and so it was a big amount of memory to keep. So imagine you have like a lot of policies that were hitting the PolicyServer and asking context-aware resources in a different way. You would have this idle RSS to be even bigger, especially then when using gatekeeper policies, because then we cache the whole inventory there. So there was some stuff that was going on that it wasn't really optimized well. And so with no fixes, the max RSS refers to the burst. So when we hit the PolicyServer by using the load testing tool, we use K6. I don't know if someone can, maybe it's interesting, maybe not, can link the repository of our load testing tool to the chat. So yeah, basically we mimic, I think 20 users, Flavio, 20 parallel users that start hitting the PolicyServer, yeah, like crazy for an amount of time, which is a minute. And then we calculate the average HTTP request duration. And the max RSS is the maximum memory, resident memory that the PolicyServer has consumed, and the idle RSS is after having all these users hitting, then we have some calm, and then that's the idle RSS there. So going back to the topic and what we started to think, we started to think that the problem was the store, since those resources were kind of like occupying a lot of memory. We contacted maintainers of Kubewarden, and they mentioned that especially pods with a lot of variables are being very noisy in the memory, let's say, very spacey. And so we started thinking, well, if the problem is that we store a lot of information in memory, then the fix should be not store that in memory. And the first thing that we thought, it would be, okay, let's put some sort of database there, and let's try to offload everything that we had in memory to this database. And we thought about SQLite because it's slim. We could be ephemeral, so we could have like a file. It's easy to test because we can also run SQLite in memory, so we could run some unit tests. So there were a bunch of reasons, and also it was it's mass appealing as well. So it's easy to find libraries for Rust that deal with the SQLite. And so we started the POC, and we failed. So and that, yeah, the main reason was once we did the POC, we started realizing that the burst was still there, and this memory wasn't really released to the OS. It was lower because we had like 492 megabytes of bars, but still we were keeping 480 megabytes in memory. And the worst part was that we were going from 400 milliseconds average on under heavy load. That's on my laptop, which is, maybe it's not really significant, but it's i9 with, I guess, 32 cores and 32 gigabytes of RAM or 64. So, and then we had 158 second to serve a request, which is, pretty huge given I don't have a Blade server, but that's like Commodore 64 kind of like performances. So we started like thinking what could have been wrong, and we decided to profile it. And yeah, so when I say that we failed, it's the problem that we might have needed to profile it before starting even thinking about providing this RFC. But yeah, lesson learned. We started to spin up a few tools for one for Rust, which is called ByteHound, or using the malloc, jmalloc pprof capabilities from TKV, I think it is. Or yeah, well, it's bundled, but TKV,
Yes.
yeah, they did a crate which wraps it nicely for Rust, so you could actually switch the global allocator from system allocator to gmalloc, and then instrument gmalloc to run to do pprof, to output pprof files. So you could look at FlameGraph with the Go tool. We are already doing that for CPU. So yes, it's I have to say it was a little bit clumsy how we got there. But at the end of the day, looking at the stats, we realized that yes, the performance loss was on the SQLite side, first thing. So we were losing a lot of time on not querying, but RAID radiating the list that we should send back to the user. So in case like you ask with client Go for a list of resources, you get back an object list. So for instance, for pod, you will get a pod list, which has some structure with items and all the pods. And yeah, to rebuild this from the SQLite store, we were losing a lot of time because we needed to like deserialize, deserialize and serialize back to the object list every row that we store in the database. So first thing, like performance loss, SQLite to blame. And the second one, which was funny, we looked at the memory flame graph and we realized that the burst was occurring with or without SQLite, because something that was happening in the underlying library that we use to interact with Kubernetes, which is kuberes. And so that brings us to the next tab, which is the PR, which fixes this. And it's a PR that we open against kuberes, where there is some sort of state machine within a stream that deals with fetching the initial list of resources and then updating that initial list of resources once an event is coming from Kubernetes. So the first step for a reflector is like to fetch the whole list, and then it starts the watch, and it updates the list with the, if an object is deleted, and then it gets deleted and it emits an event, and this event is captured, from it's handled by the store, and the store removes the object from the store in memory. And so the main problem was, while fetching the initial list, everything was being buffered before being given back to the store. causing a burst. And then there was the store that was storing that in memory. So we actually were having a double burst of memory. So the first for the fetching of the initial list, accumulating, and then giving to the store. So, copying this data in memory store. So we actually noticed, double buffering. And that was weird as well, because the list watch strategy had some sort of pagination. So we were expecting that we would burst as much as the page size. So while reducing the page size, this wasn't happening. That's because, yes, it had pagination, but it was still buffering in the same vec. So at the end of the day, we contacted the Kubewarden maintainers, and we agreed on trying to fix this for good. And so I will show you the results. Those were like our manual tests. They were not run in PolicyServer. We had we built a CLI tool that was watching a certain resource in a certain namespace. And so we had some tests with the upstream version. We had 92 megabytes for 10,000 row buildings and 76 without the store. So the store doesn't really matter. The problem was the burst. And then with the store, we had with the patched version 58 burst, and without the store 13 megabytes, which actually makes sense because that's the size of the store. And then there's also the same patch for the streaming list strategy, which is something that is under FeatureGate, or yeah, it's under FeatureGate in Kubernetes, and it's another way to populate this initial list when watching a resource, by using streams. But we are using the list watch strategy because it's not in beta, so it's as simple as that. And also the Kubewarden maintainers that I thank for the patience of dealing with with all the questions, and also having this review in a really fast way. They ran their test, and then they started running a controller, because Kubewarden is the lower level library. On top of that, you can build controllers, and then controllers, of course, watch for resources. So they use reflectors in Rust. And so they had this real cluster with 2000 pods, and they showed that after this patch, the memory burst was basically eliminated. And so that brings us to the last optimization. So while playing with memory allocation, profiling, we also had the chance to try jmalloc, which is an alternative allocator. Actually, it was the default allocator for Rust, I think, till 2018, or I don't remember.
I don't remember exactly, but
yeah,
at
but and then they changed it to the system allocator. So
the reason it was they changed that not because it was performing bad, but because it was making the final binary size bigger, and so they wanted to have smaller binaries.
Yes, and also they wanted to have something standard, so when they wouldn't, force the user with an opinionated choice. But by removing the jmalloc custom allocator, they also introduced something that allows us to switch the global allocator from the system allocator to something else. In our case, it's jmalloc through the jmallocator crate. And so we had some tuning of jmalloc, and we are basically optimizing it for high resource consumption application, prioritizing memory usage. And what jmalloc does that the system allocator does not is that it releases after a certain time the memory back to the OS. So even if you still have the initial burst, then you're gonna release this memory, and the OM killer will be happy, and and you will consume less memory. And the rationale is that we do not really need that memory for all the life cycle of the policy server. We just need it once to fill the store of the reflector, and after that we just use deltas. So we just updates what it is updated in the store. So without fixes, we had 1.4 gigabyte RSS under load, and idle we had 1.2 gigabyte. And after the fixes, the max RSS under load, so when bursting, which also it's both the reflector and also the fact that we are hitting a lot the handlers, the validation handler, which uses WASM time. So it evaluates WebAssembly in the background. And then the idle RSS is like 264 megabyte. And the final thing that it's a nice surprise that we also reduced by almost half the HTTP request duration, which before it was like 436 milliseconds, and then it was 233 milliseconds at the end of the Kubewarden buffer fix plus gmalloc patch. So yeah, that's all. If you guys have anything to add or any question?
It's a great reduction, I have to say, no, and it's a nice example on how to tackle this and look for profiling and so on. I'm super happy also that as you said, no, that the maintainers of Kubewarden were so welcoming and the PR was merged relatively, fast in a way.
Yes, that's very nice. And Kubewarden is also a CNCF project, so we are happy to be adopters. So yeah, so that was fun.
Yeah, it's always fun, no, to get in contact with the upstream maintainers of the different pieces. Okay, do we have anything else on this topic? I cannot think of anything else.
I think Flavio had the Audit Scanner, which also kind of like relates to that.
Yes, maybe we can jump to that.
Yeah, sure. So this is another improvement that has been done to during the 1.13 release. So community reported back that as you know, the policy server can be baked by multiple instances. And so this community user had the policy server baked by 3 replicas. And he had a lot of policies, and so when and a lot of resources to inspect. And he noticed that the audit scanner was taking quite some time to complete. And looking into all the metrics that we emit, it turned out that it was pretty obvious that all the requests were sent to just one instance of the policy server. So there were 3 policy server pods because the replica size was 3, but all the requests were hitting always the same policy server pod. And we looked into why that was happening. We initially thought it was an issue with regards to how the load balancing of a cluster IP address of Kubernetes is handled, and so we thought it was something specific to the CNI being used by this user. But it turned out that we were able to reproduce the issue also using another CNI, and so it was definitely something else. And so after a lot of digging, it turns out that we learned something new about how Go behaves. So the audit scanner is written in Go, and we, for each resource that we are auditing, we make several HTTP requests towards a policy server where the policy is being hosted. And so we use the standard library of Go to make these HTTP requests. And it turns out that by default, the Go standard library keeps a connection pool of all. So you send a request towards a web server, it creates a connection for it, and it keeps this connection warm. So that if you have to make another connection toward this web server, there's no need to instantiate a new connection towards that. It just reuses the one that is already there, saving a lot of time. But there is, of course, the side effect that all the requests are always sent to the same server. That's because usually after some time that the connection is not used, the standard library of Go will just drop it, and so that when you create a new connection, a new one will be instantiated, and maybe you will hit another server. But with the Audit Scanner, the decay does never happen, because we're going so fast through all the requests that we ended up reusing the same set of connections. And so the fix was just one-liner. It was about disabling this connection pool, and immediately we saw that the load was spread across all the different replicas. The way the load is spread is something that now we cannot control anymore, because now it's up to the CNI of Kubernetes. So if you are using, if you're using a Kubernetes cluster where you have kube proxy using IP tables, then each IP tables rule that is created to translate the virtual cluster IP address into a specific pod address, it has its own load. And so there is going to be some round robin fashion across all the different instances that are there. Sorry. So the load should be spread in an even way. If you are running on a Kubernetes cluster where you are no longer using IP tables to achieve that, then the load is going to be spread in a different way. What is important is that the load is spread across all the different instances of a policy server in basically in a fair way. We went back to the user, and he saw a reduction in time when it comes to doing a full scan, but still it was taking some time to complete that. And so we went back and looked into the source code, and there are some actions that we do in a parallel fashion, so that we analyze multiple resources at the same time. But there were other pieces of the code where some parallelism could be done. And so we changed that with the latest release. Now, let me share my screen just to... Yeah, you should be seeing that.
There it is.
Yeah, you see the audit scanner, yeah. And so here, this is the README of the audit.
Oh, I lost Flavio for a moment. I don't know if I'm the only one.
No, it's same here.
I think he crashed.
Could be. Okay, meanwhile, I think I can just share the... Okay, now I'm sharing. And I don't know what I'm sharing. Okay, I should be sharing. And now, okay, now you should be seeing the audit scanner README. I hope that you're seeing the audit scanner README.
Yes, I can.
And perfect. Then maybe we can go through here for the audit scanner topic and see if Flavio can join us later on. So as Flavio was saying, now the audit scanner has more features. You can see we have added here some new flags that parallelize the run of the audit scanner. We can see it here in the tuning part, where we can set the page size that we already had for seeing how much chunks do we do at once. And now we have these new parallel resources and parallel policies, which tells you exactly that. You first go through all the policies, And then for all those policies, you will find all the resources that apply to them, and then you create the synthetic requests for all those resources against the policies and so on. And we're doing that in a serialized fashion, going through one policy first and then the next one and so on. So now you can trigger that for several policies at once. And once you are in that policy, you can trigger that for several resources at once. And with that, we have reduced the amount of time that one needs for dealing with these synthetic requests that we will create and then get sent to the specific policy server of that policy and run and so on. So yeah, that's it. This is of course useful for really big clusters that we were talking, such as clusters that have thousands of resources or pods and so on. And of course, this is part of the Audit Scanner. This is the Audit Scanner binary that it's part of the image of the Audit Scanner that we see. But this has been also exposed in the help chart. So if you are an end user and you are deploying the Kubewarden controller, here in the values, you can see Audit Scanner. And then as usual, you would see the different values that you can set. And here we have per namespace, resources, and policies. And I forgot to say about the namespace. Of course, the Audit Scanner goes through all the cluster admission policies, and then it goes through specific namespaces, and then for those specific namespaces, it goes into the policy and so on. So with this, you can parallelize the namespaces, the policies, and the resources. I suppose that basically, yep.
Yeah, one thing to consider is that, when dealing with parallelism, there is no magic number that we can, ship as, okay, more parallelism then it means that it's faster. So we let the user decide, and experiment with and tune those parameters. And I think it's very powerful for advanced scenario where then the user, will find its own benchmark and figure out what is faster. So yeah.
Yeah, you're totally right there. No, this would need adjusting for the specific type of cluster depending on your size and style of cluster. But yeah. And also, I think we may have fixed some Audit Scanner simple bugs, but yeah, nothing important. And talking about bugs and fixes, maybe we can jump to the next topic, which it's about the controller. And in that sense, I'm going to stop sharing. I suppose, Jose, would you like to talk about it?
Yeah, sure. Yeah, this is a conclusion for what we mentioned in the previous community call, where we start to talk about these improvements. So we finally finish everything in release. So we simplify our controller code and make it easier to maintain and further improve in the future. So by doing what that means is that we now use owner reference to handle the deletion logic. So we remove that from our controller and rely on Kubernetes feature. And we also start to use helper function to decide if a resource should be created or patched in our case, which is a helper function available in controller runtime library. And that remove a lot of logic and simplify a lot of our code. And by doing that, we also simplify and reduce our code line number, basically. And to ensure that everything is still working, we add more tests and reorg our tests to make them more reliable and better to test our code base. So that, as mentioned, improved a lot of our code coverage testing by 23%, which is kind of a lot.
Yeah, it's
And
quite big.
yeah, and that's already released. So that's the main things that we mentioned before, and now it's released. Beyond that, we also improve actually enable cache for two types of resources that was not cached before, which is config maps and deployments. We disabled that in the past to avoid getting out of date resources, doing some past issues, but now our controller has a maturity that this is not a problem anymore, so we can enable cache again. Tests are passing, everybody is using without any issue, so that's fine. And that's come also from a user request, which is ask us to reduce the hits in the API server, so we enable cache to specifically reduce this kind of load in the Kubernetes API server control plane. So that also is a performance in a sense, and yeah, that's the main changes in this release. And I will take this opportunity to mention the next one, which will be we pay a tech debt by following best practice and update our finalizers to be domain qualified. So that will be released probably in the next release, and that's also it's not in this release, but it's kind of very close to the release. So that's another thing that we can wait for the next release. So that's all.
And that reminds me, so you were saying about paying tech dev, no, and doing the housework. It's super nice to do these kind of things and have a good code base and so on. And you mentioned reduction in number of requests done by the Kubernetes controller. Do you remember the number? I have the number here. It's just
I think this is almost a half of the requests.
yeah, that's what I'm seeing, which is super nice. You know, I mean, reducing number of requests, better performing, plus better code base. Sounds great.
Yeah, and that's also related. These reduce of requests are also related to the refactoring, because some of these requests are like try to create and get no, it's already there response. So that's will handled by the creator and update helper function. And then other ones which get too much config maps, too much time is handled by the cache. So it's kind of related changes. So yeah.
That sounds great. Okay, I suppose next topic. Let's keep moving forward because we are on an agenda. Next topic would be the cell policy, which we have hinted about, and we can share how is it going. And we can say that we are closer to releasing 1.0 for it, and we are getting more confident, and we have done great changes to the UX of our own extensions of cell. So in that topic, maybe I can do a quick, I can show a quick example on how that will be part of the documentation of Kubewarden. And that would be how to, now you should be seeing the screen, which I suppose you are seeing. So cell in Kubernetes has been there now since some releases, and now with 1.30, it's going to be part of the stable features of Kubernetes. And part of that is are validating admission policies. Here we see a validating admission policy, and we can do the same in Kubewarden by using the new cell policy, which is, as we have hinted in the past, it's a cell policy written in Go that bundles the cell Go upstream interpreter and bundles the Kubernetes libraries that Kubernetes uses in the API server and uses for their admission controller that have cell. So as you can see, it's quite similar. You can see, for example, the match constraints, which we will have here in rules. And then here we can see the variables and the validations. In our case, would be settings variables and validations. And basically, the rest of the things are more or less the same. We have similar features, but being a Kubewarden policy, we will have features that are not on the validating admission policy, which is being able to do context-aware calls and being able to reason about audits of resources that are already in the cluster, being able to run this kind of policies in clusters that don't have validating admission policy for so far, and things like that. So if you are curious about this, I would say go to the policy which is the Kubewarden cell policy, and you can see the progress there. We are closer to releasing this, and also we have some feature requests for the future that would be nice to have. But yeah, that's it. What can I say? I can show, for example, if you go to the policy and you go down, you would see, apart from the Kubernetes libraries that Cell has, and we have bundled with the policy, we have the host capabilities of Kubewarden that we are shipping with the policy. This is our Cell extension libraries that we have added. So in this case, if you click here on the capability, you would be going to the docs kubewarden.io, reminding you of what is that about, for example, Sigstore. And also you see the documentation. If you click on the documentation, you can see the documentation that would show you how to write things in Cell. And here, maybe, Fabrizio, you would like to talk about a bit of the UX that we have achieved here.
So yeah, one thing is like yeah, the rationale to even start with this Cell Go policy was to yes, mimic Kubernetes validation admission policy, so that a user could easily migrate. Maybe you are a user, you have like the validation admission policy feature gate enabled, or you will, because now it's in stable 1.30. I think it's gonna be shipped as
it's on by default with 1.30. Yeah.
Okay, it's on by default. Okay, perfect. So maybe you want to start, with some simple policies, but then you start needing, I don't know, multi-tenancy. You want, some policy to be executed in certain policy server. You want to, for instance, having metrics and tracing. You want auditing, as Victor mentioned a few seconds ago, and you also want to use those context-aware capabilities. And for us, we had quite a lot of requests where some type of users, some persona, they were asking for a DSL, so some way to write a policy without having to deal with a language toolchain, and then compile it to WASM, and maybe they don't have their own registry and they just want something quick. So the power of this Cell policy is that you can use whatever existing validating admission policy you had with the few limitations that we are working on. And here, yeah, Victor is showing the translation. But also, you can use all the power of Kubewarden, for instance, like the Sigstore integration, the Kubernetes context-aware calls, the cryptography, and then yeah, about the UX, we're trying to give the user something which is nice, because writing expressions in YAML inside a YAML string could be awkward. So we're basically using the same pattern that Kubernetes uses for certain capabilities, such as outs. And so yeah, there is like a builder pattern, and as Victor showed in the Kubernetes documentation, it's quite easy to understand and to build a request without having to getting crazy with a lot of syntax. So it's also like easy for maybe operators that are not familiar with coding, but they are familiar with something like GitHub Actions, for instance, or Kubernetes. So yeah, this is I think the catch here. Yeah, and also we are going maybe in the next release to implement something which is called match conditions, which is already inside Kubernetes. I'm not sure if this is on FeatureGate. I think in 1.30 then it becomes stable. So
it's already out there.
It's already out there. So
yeah.
Match condition is a way to filter policies. So you could say, okay, this policy is good, but then you write your own Cell expression, which has the request as an input or the object, and you can say, okay, and please skip everything that comes from this namespace, or a pod that has this type of label, and all this kind of stuff with Cell.
There was, if I can jump in, there was actually a user from the community who wanted to achieve something like that. So you had the policy enforced inside of a cluster, and you wanted this policy to always be applied, maybe inside of a set of namespaces. So it was already using a namespace selector to apply a policy, a cluster admission policy to multiple namespaces. But you also wanted to do something like, I want this policy to always be applied inside of these namespaces, except when the request has been made by this special user. So inside of a admission request that an admission controller validates, there is a portion of it where you see who initiated the operation, who is trying to create, update, delete something. And this is something that Kubernetes fills in. And so with a match condition, you could say, all right, I'm going to reject that, except when as it was highlighted, as when the request user info tells me that this user is a member of this group, all right? So this is pretty powerful and something that we will be able to leverage, yeah.
Yeah, and the match conditions is not limited to the cell policy. We want to add this to the admission policy and cluster admission policy CRDs, so they will be available for every policy. Also, the one that do not use cell, like standard policies that you will find in Artifact app, or the one that a user can build with WebAssembly. And I don't know if it's time for a sneak peek for the future, or
can I share something more? So there are more reasons why using cell and VAP inside of Kubewarden is pretty cool. And so aside from what has been said, being able to do context-aware policies, to query Kubernetes, do Sigstore and all of that. So you have also you gain all the insights that Kubewarden offers you. So the telemetry, the metrics, all is in there. You are also going to be able to use a policy reporter so that you are aware of I have these resources that are already inside of a cluster and they're not compliant because this cell policy I have is not happy. And these are all things that you do not get with VAP. So this is a nice improvement. We're not trying to tell you do not use VAP, because VAP is pretty powerful and can still be used together with Kubewarden. This is just more flexibility that we're giving to you without having to rewrite policies that you already have.
Plus the cell code from a VAP or from in the other way, the cell code from a Kubewarden cell policy, it's backwards compatible, with a VAP.
Yeah, we are using the same code base, basically. Yeah.
Exactly.
Yeah. We just extended it. So if you are using a Kubewarden policy that is using Sigstore capabilities, of course, you will not be able to run that on top of VAP. But you can take anything from VAP and run it on top of Kubewarden without any change. We will also work to provide you some migration tool to simplify that process, instead of having to copy and paste the YAML by hand.
Yeah, I suppose we are looking forward to also, we have seen in the cell policy repo, that we have already some users, even if we have not publicized this policy, that are already asking for things and saying, when is it going to be ready? So yeah, we share the same enthusiasm, and we also look forward to anybody that wants to come forward and say what they are thinking or what they would like. And on that topic, Flavio, this reminds me that you have a talk on cell and cell policies and VAP upcoming.
Yeah, so if you happen to live in Italy, or if you happen to speak Italian, I'm going to deliver a talk that is going to be recorded and made public about cell, VAP, and this Kubewarden integration. Is going to take place on next week, in 1 week from now, so on the 20th of June. It is Kubernetes Community Days Italy. The talk is going to be in English. The slides are the talk is going to be in Italian. The slides are in English. So yeah, if you happen to be
Sounds
around,
fun.
just say hi.
I hope that we get to share that in the next days and have fun as always. Okay, I don't know. Do we have anything else for the cell policy? If not, I propose to move to a different topic, because we are coming short of an hour right now. Okay, let's move to the next topics. On the next topics, we have what's coming next. And for that, we noted the group policies on the list. Fabrizio, would you like to give a little sneak peek?
Yeah, so this is kind of related with cell, but yeah, so what we were asked from the user was the possibility to combine, several policies, and then to build a complex policy. So let's say you have a policy that checks the source signature of an image, and then you have a policy that checks that the image tag should be not the latest one for and then you want to combine those together. What we can do now, it's like build a new policies that incorporate both logic, and then have this policy shipped to an OCI registry, and then with all the complexity of adding a new project, and then maybe you want to change that, and then you end up writing a lot of code. So the idea was to simplify this process by providing another kind of like meta resource, which is called group cluster admission policy or group admission policy, depending if you want the policy to be cluster wide or not, where you could actually add a list of policies with their settings, and then having an expression, which is a Boolean expression, which like you can tune for your need. And then we were thinking, and there is already an RFC in review, to use cell for building this expression. So a user could have like something familiar on what we've shown now and to the VIP, and also like very powerful, because if you mix together, yeah, this is in review, so disclaimer, things can change. As a
You can also influence that design. So if you go over the
Correct.
RFC repository,
Exactly.
you will find
Yes.
the open pull request. You can feel free to comment.
Yeah, so this is an example CRD that I think it's very useful as an example. So you have like a bunch of policies.
Can
and
you
then,
zoom in, please?
Yes, and then they accept
Yes, maybe
pods.
something like this.
Okay, they
Yeah,
accept
thank you.
pods as a resources for the operations create update. Then you have the bunch of policies defined as you would define a single policy, and then you have an expression that gives you the possibility to put those policies in in a relation together to combine those. So either it passes the SIG-store PGP with the provided keys, or it's coming from a GitHub SIG-store keyless GitHub action. He has a SIG-store keyless GitHub action signature with the owner Kubewarden. And it also rejects the latest tag. So if this expression doesn't evaluate to true, we just send a rejection with a message: the group policy is rejected, and some extra information about the policy that we executed, because the policies are executed sequentially. So we don't execute the whole expression. We just circuit break once we find that we have enough information to decide if it's accepted or rejected. And yes, so the combination of cluster admission policy, group policies, and match conditions, and maybe cell policies, and also like having this powerful expression to combine those, it will give a user a lot of flexibility in terms of what they can build with a single CRD, which is, I call it DSL-like because it's not really a DSL, but it solves kind of like the same problem of, that a DSL would solve, but still doing it with a Kubewarden style.
Quite good, RFC. I look forward to reviewing and merging and so on. Look forward for what the team is going to achieve. Okay. Apart from that, maybe we can talk about 114 in general, just a little sneak peek, for closing the session. And for that, I've opened here the milestone as usual. Everything is it's in the open. You can influence and you can have a look on what are we working on. And I'm curious about what we have there. We were talking about host capabilities before because of the shell policy, and I see fetching the container image config. That we are going to add a new host capability for that. Jose, some words on that?
Yeah, that's come from a user request. The user wants to check the user defined for the container image, and that's available only in the config of that image. So we need to add that host capability to then update the policy to perform that check. So that's in progress. And that's work is in progress.
Yeah, great. I see also the adding taints, tolerations, affinity, and anti-affinity globally. We have been working on this now in the last releases, or we have added anti-affinity and affinity, and so on. And there's this comes also from a user asking for being able to configure that globally for the whole cluster. For the whole deployment of Kubewarden. That would mean that you just set all of that in the Helm chart, and then when you deploy Kubewarden, the things, the images and the deployments and so on would be configured with taints and toleration, so they would go wherever you want them to go, which is great. And yeah, we look forward to that also. And then we have some enhancements here and there that I don't want to spoil much. I don't know. I mean, I'm looking at specific things.
Just wanted to point out that this is going to be, we want to keep a monthly release cadence, and we were a bit late with 1.13. So this is going to be a smaller release because we want to go back to the schedule. So we have less development weeks ahead of us. I think we have 3 weeks ahead and before we tag another release.
Yep, totally true. I mean, it's great, no, to have a cadence and just, we release things when they are ready and that's it.
Yeah.
Okay. So I suppose that would be it for today's meeting. Folks, if we have any other topic, I suppose for right now, no. For those listening from home, many thanks for joining us. If you have any topics that you would like to talk about, join us as always on Slack or add things on the office hours topics doc. And with that said, see you around and enjoy the rest of the day. So
see you. Bye-bye.
See you. Bye-bye.
See you guys. Bye-bye.